Hello and welcome to INA's CCI's Service Provider version 5 Learning Path. Today in this course we will talk about ISIS path selection. Now ISIS path selection, to understand that you must first understand the metrics of ISIS. Like how in OSPF we had metric was cost, and in EIGRP we had bandwidth, delay, reliability, load and MTU. RIP had hop count. ISIS also has 4 different metric values. We have default metric, which is always 10 by default. So every link has a cost of 10, or every hop count of a router has a cost of 10. We have delay, which is similar to how EIGRP uses delay. We have expense, which is the actual monetary cost of a link. And then we have error, which is similar to how EIGRP uses reliability. However, Cisco routers only support one metric, which is the default metric, which is always 10 by default. So whether it's a fast Ethernet or an Ethernet or maybe a T1 or an OC 48 link, it doesn't really matter. The cost is going to be 10. The maximum metric that you can define for ISIS is 63. So I could go to an interface and change the metric from the default 10 to 63. But you can change this behavior. You can change this behavior by changing the metric style to wide. So if I actually go to a router and let's say if I go and give the metric as 100, you would see the following error saying that metric cannot be greater than 63 because metric style wide is not configured. So depending on whether it's iOS XZ or iOS XR, so default is metric style wide, depending on the type of router. So what we'll do right now is we will look at a topology where we would have maybe six iOS XZ routers, we would have 2 XR routers, and we'll look at the topology table of ISIS and look at how metrics are basically calculated. We'll see that the default value is 10 and which path ISIS is taking. We can always do a path manipulation by changing the metric. So let's pull some routers out. So here I have some routers. Let me in fact pull all the routers out. So I have 1, 2, 3. I have 5, 6, and let's get 4 also out. So I have 1, 2, 3, 4, 5, 6, and XR1, XR2. Let's look at router 2, which is basically an iOS XZ router. And let's do a show CLNS interface. Let's do a pipe to include line protocol and metric. As you can see here, I have many interfaces. I have an interface on R2 which connects towards router 1. I have an interface that goes towards router 3 and router 4. So I have 3 neighbors at this point of time. Show ISIS neighbors would show me that. I have 3 neighbors. And look at the interface metric. So on all my interfaces, I see that my total metric is 10. That's the total metric on that interface. So every link has a default metric of 10. You can always look at the same thing on XRV also. Let's check XR1. The command would be the same, show ISIS interface. Let's go back to exec prompt and do a show ISIS interface. And let's do a pipe to include loopback, gig ports, and metric. So as you can see here, whether it's a loopback or whether it's a gig port, my metric that you see here is going to be 10. That is the default metric. So whether it's an iOS XZ or an iOS XR, doesn't really matter. The metric is by default going to be 10. Let's also look at the routing table. Let's go back to 2 and see how is R2 reaching maybe XR1's route or maybe XR2's loopback. So if I do a show IP route to 20.20.20.20, which is the loopback of XR2, I have 2 paths in my routing table. So I have a path through R3 and I have a path through R4. So ISIS again does load balancing automatically. So if the metrics are same, if the number of hops are same, which means my metric is going to be same by default because each link has a cost of 10, ISIS is going to do a load balance. obviously, the load balance mechanism is going to be as per Ceph. So whether it's based on source or destination, or maybe based on flow, depending on what you've configured. So here I can see that R2 is doing a load balance between R3 and R4. Let's do a show ISIS topology to reach XR2. Here I can see that again he is doing a load balance and the total metric is 40. So that basically means that there must be one router R3 in the middle, maybe there's R6, there's XR1 and there is XR2. So there are 4 routers in total after R2, which gives me a total metric of 40. So 10 is basically like a hop count. So every hop of a router has a metric of 10. So since there are 4 routers ahead of R2 to reach XR2, my total metric is 40 to reach XR2 through R3 or R4. So if I go back to, let's say, R1 and do a trace route to 20.20.20.20, that's going to show me my exact path which it goes through. So it goes to R2, then R4, it goes to R5, XR1, and then XR2. Similarly, if I want to look at XR1, and if I do a show route IPv4 1111/32, again XR1 has 2 paths to reach router 1. It could go through R5 or it could go through R6. Because the metrics are same, it shows both the path in the routing table. Obviously the load balancing is going to happen based on the flow as per Ceph. So again, if I do a trace route, it may select one path over the other depending on the flow. So if I do change my metrics, of any of the interface, it would not do a load balance and my topology would not show both the paths. So let's go to maybe one of the router and change the path. So maybe on R2, if I go and increase the metric of an interface towards maybe R3, then R4 or then R2 would take the path through R4. Right now, R2 has 2 paths, right? Through 3 and through 4. It has 2 paths. It is doing a load balance. But if I increase the link cost to R3 from 10 to maybe 20, then he would select router 4 as the only path, the best path goes in the routing table. So let's go back to my interface on R2, gig 1.23, which is the link to R3, and say ISIS metric. And here I can specify the metric. Let's try and give a metric which is higher, let's say a 100, and say maybe level 2. I don't need to define the level. This could be for level 1, this could be for level 2. By default, it's for both level 1 and level 2. But if I do want to change it for a specific type of level, then I can, just for level 1 or just for level 2. Since all my routers are running level 2 only, I could do level 2. The minute I gave this command, it gives me that error saying that, hey, you can only set the value to be not greater than 63. 63 is the maximum because the default metric style is narrow, so it's not wide. You have to set that to wide if you want metrics to be higher than 63. So let's go and change this to maybe 40 and change this for just level 2. And the minute I do this, if I go back and look at my routing table, I only have one path now through R4. If I look at my topology to reach XR2, it is, again, my metric is still 40 through R4. I didn't change the metric towards R4. I only changed the metric towards R3. So my metric basically increased by 30 because I actually gave 40. The default was 10 and I increased it by 30, totally making it 40, which means that my metric totally through R3 should be 70. If I actually shut down the link to R4, I should see that. Let's go to interface gig 124 and shut this link down and look at the topology again. I should see that it should route through R3 and my total metric is 70. So you can change this behavior by increasing the metric greater than 63 by changing the metric style to wide. Let me go back to R2 and do a no shut to my primary link. And let's change the metric on XR1 also. XR1 again for reverse path, it has 2 paths to reach router 1. Remember, whenever you change a cost or change the metric, it's always outbound effect. So if I change it on R2, it's R2 going outbound on that interface. The metric is changed. It's not for incoming routes or incoming traffic. It's only for outbound traffic. Similarly here, if XR1 wants to get to R1, it has 2 paths to go through R5 or R6. Let's change the metric towards the link to R6. So XR1 goes to R5 only. So that's going to be done by saying config T. It's done under the ISIS process, under the interface, under the protocol. So show ISIS1 interface gig 0000.6.5, in fact 619, which is towards R6. So config T, router ISIS1, and interface would be gig 0000.619. And here I can change my metric. So if I look at the metric command, it doesn't really exist here. You have to go inside the address family under the interface. So address family IPv4, and here I would say metric and set the metric that I want. Can I give higher than 63? Let's try 100. And do a commit. So I basically gave a value which was greater than 100, but level 2 is configured to generate narrow metric, so which basically means that I cannot give metric higher than 63. So let's change this, let's remove that, and then re-give the metric to be maybe 40 and commit. Once I commit, if I look back at my routing table, I should only have one path, which is going through router 5. So I'm not using the path through R6 anymore because of shorter path through R5. The metrics are not the same. So you see, we can always do path manipulation by changing the metrics of an interface. Just one thing you must remember, that you cannot give metrics higher than 63 because the default is narrow, so it has to be metrics lower than 63 or equal to 63. And every hop count of a router is basically by default 10. That's the default behavior in ISIS. I hope this video was informative to you, and thank you for viewing.